So today we're going to talk about, we're on 8B.6, and today we're going to apply the 3 properties of logs. Apply the 3 properties of logs. When we are talking about logs, what are they basically? Logs are just another way to write what type of problems? Exponents, okay? So I want you to be thinking of, since logs are exactly the same as exponents, logs are exponents. So the rules for logs, are the same as those for exponents. It's probably mine. It's okay. So the rules for logs are the same as those for exponents. Seriously? It's a little crazy. So the rules for logs are the same as those for exponents. Okay, and when I'm talking about rules, what I want you to think about is, if you remember when you multiply, okay, if you're multiplying seriously? Come on. I'm not doing well today. X to the A multiplied by x to the B power. If you're multiplying 2 things, what do you actually do with our exponents? If we have the exact same base, what do you do with our exponents? Add them. So this would become x to the A plus B. So in your head, I want you to remember that multiplication and addition go together. Okay, multiplication and addition are kind of linked together. Okay, so we're going to first talk about something called the product rule. Okay, what does the word product mean in math? It means multiply. Okay, so the product rule tells us that log base b of m plus log base b of n will equal log base b of m multiplied by n. So log base b of m plus log base b of n is equal to log base b of m multiplied by n. So just like with exponents, multiplication and addition go hand in hand, same thing here. Okay? Addition and multiplication are linked to each other. Okay, so essentially this plus, you can consolidate, we can write it as just one log, but you write it as a multiplication in between the 2 of them. Okay, so you'd see something kind of like this for number 1. If I gave you log base 6 of 3 plus log base 6 of x, and I ask you to condense. Okay, this is called condensing logs, or combining them. Now, given you have to have the exact same base, okay, we're never going to give you problems that don't have the same base, but if you have the same base, this multiplication or this addition can turn into multiplication. You can consolidate, so you only have to write one log. So this becomes log base 6 of 3 times x, just 3x. That's what I'm looking for today. Okay, I'm looking for just consolidated or condensed answers. Okay, and that's it. So remember that addition turns into multiplication. Questions? It's just something that you're going to have to memorize. There's 3 different rules. You're going to memorize them. First one is that addition turns into multiplication. Okay. Next one I want you to kind of remember is what happened if we had x to the a divided by x to the b. What happened if I had x to the a divided by x to the b? What would you do with those exponents? You'd subtract them. Okay, so this would become x to the a minus b. Okay, so remember when we were dealing with exponents, that divide went together with subtract. Okay, so division and subtraction kind of go together. Those are linked together. There's also a rule or a property with logarithms, it's called the quotient rule. Okay, quotient hopefully keys you in to think about division, because quotient means divide. And the quotient rule tells us that log base b of m minus log base b of n is equal to log base b of m divided by n. Okay, so again, just like with exponents, division and subtraction go together. Logs are exactly backwards. Subtraction turns into division. Okay, that subtraction turns into division. And the way you're going to see that is something like for this, for number 2, if I gave you log 17 minus log 13. Log 17 minus log 13. And I asked you to condense that. So condense basically means I only want you to write one log. First off, do these have the same base? Yes, what is their base? 10. Base 10. Okay, we don't have to write it, but if you wanted to, you could write it in the base 10. Then you need to know that because of the quotient rule, subtraction turns into, we're going to consolidate and just condense it, write one log, and this one always comes first, this one always comes second. So 17 over 13. That's your answer that we're looking for. Log 17 over 13. That's it. Questions on how I did that? Okay, and then the last rule that I'm going to give you is something called the power rule. This one you've probably never seen before. It doesn't really have an application with exponents. Okay, but the power rule tells us that when you have a log base b of m to the p power, essentially what this does is I want you to think about walking a dog. Okay, if you are a responsible dog owner, when you go to walk your dog, what do you take? And don't say, okay, and you take a dog, and we're not talking about plastic bags. No, we're not talking about plastic bags. Okay, but if, technically in the city of Clovis, you cannot walk your dog without what? A leash. Okay? I was not talking about poop, sorry. We were really going for a leash here, I promise. Just had to take it there. Okay, so this dog, my power dog, is on a leash. Okay, the reason we have leashes is it can only go as far as I want it to. Okay, this power dog can only walk this far. Its leash is only that big. Okay, it cannot walk in front of other logs. It can't combine with other logs, and you'll see why this is important when we do a couple more examples. But just remember, our power dog, it's on a leash. It can only go to the front. Okay, so this becomes P multiplied by log base B of M. Okay, so it actually multiplies out front. So the power can walk out front. We're going to walk our little power dog, and then it can multiply out front. Okay, so that's going to look something like this. If I asked you to condense log base 3 of y to the 4th power. Log base 3 of y to the 4th power. So just like in the power rule, this little power dog gets to walk. Okay, it's on its leash. It can walk up to the front, and it becomes 4 multiplied by log base 3 of y. You don't have to put the multiply dot. You can if you want to, but you don't have to. That's all we're looking for. Okay, it's just knowing that what those rules do, essentially. Okay, so those are the 3 rules. Now we're going to ask you to use them. Okay, so I'm going to ask you to condense the following. Okay, so condense, whenever we're condensing, you need to have an answer that has 1 log. So it can only say log, L-O-G, 1 time. Okay, so something like for number 4, if I ask you to condense log base 3 of 5 minus log base 3 of 20. Log base 3 of 5 minus log base 3 of 20. So subtraction goes with which rule? The product rule, the quotient rule, or the power rule? Quotient rule, okay? So it's going to turn into a divide bar. So this becomes log base 3, and again, this only works when you have the same base. I'm not going to give you any problems that don't have the same base, okay? So log base 3 of 5 over 20. Then you do actually have to condense, okay? So you do have to reduce if you can. Can I reduce 5 over 20? Yes, so we should. So this becomes log base 3 of 1 over 4. Now, not in this lesson, but in the next one that we will do today, you're actually going to simplify these. So do we know what exponent on 3 makes 1 over 4? No, so you leave it just like that. Okay, in our next lesson, there are going to be ones that you can simplify even more after using the rules. Okay, but for now, we're just leaving them like this. You're not going to be able to give an answer or to simplify it anymore. Okay, let's try another one. Number 5. Go ahead and try natural log 6. So ln means natural log 6 plus natural log 4, ln 4, plus 2 natural log x. Natural log 6 plus natural log 4 plus 2 natural log x. ln, you treat it exactly the same. Okay, if you were going to write it in exponential form, what would you have to change it to be? Log base e. Okay, but I'm not asking for that, so leave it. You can just leave it as ln. Any ideas what we would do? What do you think we're going to do? When we do order of operations, what's the first thing that you always have to look at? First parentheses, but then what? Exponents. So this front number is going to become an exponent. So the first thing you want to do is deal with the exponent. So this is going to become an exponent. Okay, so when you rewrite this, we got natural log 6 plus natural log 4 plus natural log x squared. Okay, you always want to move the exponent before you combine anything. Then, what do all these plus signs turn into be? Multiplication, so natural log 6 times 4 times x squared. And can you simplify that a little bit more? Yes, you can multiply 6 and 4, and that would give you what? 24x squared. That's your answer. Natural log 24x squared. Now, do we know what exponent on e makes 24x squared? No. So you get to be done there. Anyone have questions so far? No, you're good? Okay, I think I have 3 more. 2 more? 2 more. Okay, let's try log base 5 of 4 plus 1/3 log base 5 of x. Log base 5 of 4 plus 1/3 log base 5 of x. First thing you want to take care of is what? The exponents. Okay, so make this an exponent. That gives you log base 5 of 4 plus log base 5 of x to the 1/3 power. Then addition turns into what? Multiplication. So this is log base 5 of 4x to the 1/3. Make sure you don't put parentheses on that. Okay. Do you think there's any other way you could see this written? How else could you see it written? This is actually the exact same thing as log base 5 of 4 cube root of x. Okay? So this is the same thing. I'm not going to ask that you change them into radicals, but if you saw an answer written that way on like a multiple choice, these are the same thing. Okay? And the reason that the 4 is outside is because it's not attached to the exponent of 1/3. It is not attached. Okay, so I would take either one of these answers. Either one would be acceptable. Excuse me. And then the last one, let's try for number 7. 5 log base 4 of 2. 5 log base 4 of 2 plus 7 log base 4 of x plus 4 log base 4 of y. 5 log base 4 of 2 plus 7 log base 4 of x plus 4 log base 4 of y. Any ideas? Where do you think you'd start on this one? Bunch of exponents, okay? So walk all of these exponent dogs. Now, the reason we say they're on a leash is because this 5 can only reach to this 2, okay? Its leash only goes that far. It can't be added over to the x. None of these, they can't intermix, okay? Your exponent dog is on your leash. Stays on that log. That's it. So, log base 4 of 2 to the 5th plus log base 4 of x to the 7th plus log base 4 of y to the 4th, and all those addition signs are going to turn into what? Multiplication. So log base 4 of, you can also combine at the same time, so what's 2 to the 5th? 32 times x to the 7th times y to the 4th. And that's the answer that we're looking for. Okay, anyone have questions?